Hello everybody, this is a tutorial about how to automate RNG manipulation for Pokemon games on the Nintendo DS. You can use this on any game that is compatible with the DS from Gen 3 to Gen 5. The DS input interface is basically just a way to run frame-perfect inputs from a script, and while it's originally meant to play back tool-assisted speedruns, it can also just be used for RNG manipulation. Now, this process will require modifying the internal hardware of an original DS system, and that's not the DS Lite, but specifically the original model. This video also won't cover the RNG manipulation process or soldering skills, but there are resources that can explain those way better than I can. Though I will demonstrate Gen 4 RNG, this video is mostly focused on covering how to install a DS input interface. Timestamps for everything will be in the description, so you can skip to the hardware section to find out what tools you'll need to do this. Anyway, let's get right into the installation, starting with flashing what's called a Pro Micro board with the software we'll need. These Pro Micro boards go for around like $20 on Amazon. And basically every single thing, whether it be a file, a program, links to the hardware, they'll all be in the description. So anyway, let's start. You should plug your Pro Micro board into a Windows computer with whatever cable matches its port. Mine is USB-C. You might be greeted by this notification, but you can ignore it for now. Go to Device Manager, and you should see the Pro Micro under Ports. If it's somewhere else in Device Manager, or if it has a yellow error symbol, that's fine too. Just go ahead and right-click it, click Update Driver, and then browse your computer. Go to wherever you've downloaded the files in the description, and click on this Arduino boards main folder, and press OK. Click Install. You'll then want to open the Arduino software, go to File, Preferences, and copy-paste this URL into the Additional Boards Manager URLs box. Click OK, and go to Tools, Board, and then Board Manager. Type in SparkFun, and you should see SparkFun AVR boards listed. Install it and close the window. And again, go to Tools, Board, and then SparkFun AVR boards to choose the Pro Micro from the list. Now, this next part is very important. Go to Tools, Processor, and set it to the second option that says 5 volt 16 megahertz in parentheses. You can brick the Pro Micro if this isn't selected, so be sure to do this. Then go to Sketch, include library, and add .zip library. Choose the Arduino joystick library folder, then go to File, Open, and navigate through the main DS Input Interface Software Master to the DS TAS Master folder. It's important that you choose this one. Choose the dstasmaster.ino file, and then click the arrow button that says Upload in the top left of the Arduino program. A light on the Pro Micro will start flashing, and when it stops, you are done. Once you've installed the firmware on the Pro Micro, we can start to solder stuff to other stuff. So obviously you'll need the Pro Micro, a soldering iron, your DS motherboard. I won't actually cover how to remove this. You can just search up like iFixit, I'm sure has a tutorial. You'll also need magnet wire. I'm using, this is 28 gauge magnet wire. You can use something thinner than this, I'm sure, but this is just what I'm going to use. Some solder, some flux if you want, and then if you actually want to install a charging mod, so the DS will be able to charge through this USB-C port, I'd recommend getting like a bit of thicker wire for that. You might also want a Dremel, which is just one of these things. I'm using this bit for it to strip the magnet wire. You might also benefit from this cutting bit for it, just because you're gonna have to cut a little opening for the Pro Micro. So you can see that this one is the finished one, obviously. So when it's done, it'll look something like this. This is wider than this board, but I'll cut this one to a bit more precise size for this board. You will need to add solder to all these points on screen. One thing to note is that the VCC label might also say 5 volt, like on mine. You kind of see it. It says 5 volts, 5V right there, instead of VCC, but it's the same thing. Your Pro Micro just might be labeled that way. And now, we will have to add solder to all of these points. So this is what all those colors and numbers meant before. This is just all of these points you will have to solder a wire to, and then attach that wire to the corresponding point on the Pro Micro board. So for example, the 2 label right here, where it says P09, you'll have to attach to this point right here. That's basically it. You have to make an electrical connection from all of these points to these points. Get your soldering iron and add solder to all these points. All right, and that should be it. You can go ahead and like attach this to where you want it to be through like tape or hot glue, whatever you want to use. One thing I would really recommend is putting Kapton tape or electrical tape or something all over the cartridge slot or wherever you're going to put the Pro Micro board, just so all the points are isolated from one another. Something like this is good. This is Kapton tape, not electrical tape, but that should work too. Go ahead and attach the Pro Micro to it. And there you go. So mine is a little off, like the port doesn't line up with the middle of this, but it's fine. Alright, and at this point, you can just start soldering the wires. I would really recommend that you properly strip the wires. That's just getting rid of the insulation. Even on magnet wires, you should really do that because it helps to make the connection more secure. And the way I'm going to be doing this is I'm going to like attach one wire and then flip it over and then attach it to its point on the board and then flip it back over to do the next wire. That's just, you can do it however you want. So I'm going to use the Dremel I have to strip the wires. So a bit of the insulation is stripped off. I don't know if you can really see it, but you kind of want something like that. Once it's done, just tug it ever so slightly, and then flip the board over. Careful with the wire. Alright, once it's on the other side, you can kind of see that I routed it through this little gap between the cartridge slot and the GBA port. So if you're doing it this way, you might want to be really careful with stripping the end of this wire, just because it's already soldered to something on the back of the board here, and you don't want to like put too much stress on it. So if you have like sandpaper, actually, that might be a better alternative to using a whole Dremel thing, you know. And there you go, just do that for the rest of the wires. Alright, so here we are. I probably skipped a lot, but I mean, I will explain. Well, there's not actually much to explain, you know. I just soldered all the wires, obviously. I taped them down wherever I could. Oh, I could tape them down there. It's fine though. Just for, you know, safety. And yeah, that's pretty much it. As I mentioned earlier, the power wire for charging through this port, I did use a like proper insulated wire. My thought now is that I probably need to cut more of the back plate than I thought I would need to, because I feel like this section where all the wires are bundled up might come into contact with this, so I might just have to shave this down a little bit. I don't know if you can see it. Just this little part right here, protrusion. I don't really want to Dremel this like near my camera because I don't want like plastic shards getting into the lens. I'll show you everything I cut down. Alright, so this is basically what I did. Not much. I actually took the stylus holder out, but I don't think that's necessary at all. It's just this whole thing right here. Yeah, the main parts you want to cut down if you're gonna follow what I did, is that these need to be like totally shaved down. And I'm not actually sure about this part because I think I did it first without really testing to see if it interfered with anything first. It doesn't hurt, right? Like the whole purpose of the back plate is so you can have this little compartment for the battery. So yeah, I guess at this point, I think I covered everything, right? Here's the front of this. Here's the back. Let's put it back together. I'm actually going to hot glue over all of these connections because, I mean, all of this is exposed, you know, and you're gonna like naturally grab this to put the cable in. So just to be sure, I'm gonna hot glue over all that. I should probably say that you should only really do this if you're sure that the connections are intact, that the connections are actually connected. Alright, and as you can see, it works. Alright, once it's plugged in, you'll want to test that all the buttons are working properly, like all the connections were soldered correctly, and to do that, you want to go into the DS Input Interface Software folder, should look like this, and launch Input Interface GUI. If this doesn't launch and just immediately crashes, you want to check that no other USB serial ports are plugged in to your computer. This might be like automation for the Nintendo Switch, so like Arduino or Teensy stuff. Just make sure all of that's disconnected before you plug in your DS, and then click Connect to Serial Port, and then click Launch Input Display. And you should see this pop up. And now you just want to simply press all of the buttons on your DS, like physically. So just go through, press all your buttons, and make sure that once you do press them, they all are highlighted in red. So once you're done, close that, and go into TAS mode resources. That's Tool Assisted Speedrun Resources. And now you actually want to take out the battery from the DS and get anything made of metal, like a paper clip or a coin can work. And you'll want to bridge the battery connectors. So this just means creating a temporary connection between the two. What this does is essentially resets the DS, so it would ask you to input the date, the time, all of that. And this is useful for Gen 4 and Gen 5, obviously, because those use the Nintendo DS's time in their RNG manipulation. You will need to do this every time you want to run a Gen 4 or Gen 5 script. But anyway, once you're ready to run the script, we'll just use the default settings, which will use this opening menu.txt file for the script. So you want to make sure your DS is open, so just not closed where it would normally be in sleep mode or something. And then you want to open TAS Interface 1, and you should see your only plugged in serial port, which should be the DS. And you can see that this says 1, so you'll just type in 1 and then press enter. Then when it prompts you to press enter again, you'll press enter again. And once you see this 71G, that's the point where you want to insert the battery again. So just to recap, take out the battery, bridge the two battery pin connectors, open the TAS interface, and then insert the battery. And make sure to insert it firmly, and the script should start running. You'll see that it plugs in the name of the modder, which is Gymnast544. It'll also set the date and time to funny numbers, and resets the DS. And if you have a game plugged in, it will launch it. Alright, so at this point, we can actually start doing the RNG. What you want to do is open this opening menu.dsm file in Notepad or Notepad++, whatever. And you'll want to scroll down to the bottom here. And now, I'll actually have a spreadsheet in the description, and that'll look something like this. And this spreadsheet is what you will need for doing Gen 4 RNG, essentially. So again, I won't really go into like explaining RNG manipulation. This video is kind of assuming that you already know how. You'll open up Pokefinder, RNG Reporter, whatever you want to use. So just search normally for a seed. Once you find it, open Time Finder. The seconds can be whatever you want, and I will be using this date and time. So, how you put this into the spreadsheet, essentially these green fields are the fields that you can edit. The red ones, they're all automatically done for you. So the delay's already here, but 4514, and then our target seconds will be 35. And make sure this field at the bottom matches the game you're playing, so Diamond, Pearl, Platinum, or Heart Gold, Soul Silver. And then you will need to take note of these three fields right here, and you'll want to copy the first delay. And back in our script here at the very bottom, you want to replace this 200 with that delay. Be sure to remove this space that appears if it does. So here is the second delay, this 300 right here. You want to go back to the spreadsheet, copy that, paste it there, and here you actually want to put in A and then enter and then a second A. And the reason for this is that the Pokemon DS games will run at 30 FPS, 30 frames per second, which means that only every other frame of inputs will be accepted, essentially. So putting two inputs here assures that one of the A presses will be accepted. After that, press enter again, and insert delay in all caps, and then around 100,000 I find to be good. If you leave this at like 100, it'll send random inputs after that 100 is done, So just put that there, and then we will go to the date and the time. So here, you just want to almost copy what is written here in Pokefinder. However, the month and the day actually start at 1 on the DS. So what you want to do is just subtract 1 from the date in Pokefinder. So this says 11 for the month. You would do 10 instead. For the date, it's already 19, but you would put 19 because it's 20. And the year you can actually set normally F, so the year will be 21. The hour will be 6. And for the minute, just like an Eon timer, you want to go back here where it says minutes before target. This is 2 right now. You'll just subtract 2 from the minutes, which are 4 right here, and that would be 2. And that is it. Chances are this will work immediately. If it doesn't, there are some offsets right here that you can set if this ends up not working on your DS or game. If it doesn't work, it should only be a few frames off, which are what these values are for. So let's say the actual delay in Pokefinder right here. Let's say that was 2 behind your actual target. You would then just set this to 2 to put it 2 frames forward, press enter, and then put this new delay in your second delay. That's it for the scripting. We're going to save the opening menu.dsm file. Once you're back to File Explorer, you want to run dsm to bytes converter, and that should pop up for a second. And you should see that this file has been updated, the opening menu.txt. Then you'll want to run the TAS interface. Again, make sure you've unplugged your battery, that you've bridged the battery connectors, and the script will start running. And it'll input the correct date, which is 11/20/2021, and the right time. It'll start the game automatically once the timer runs out. And once this appears, you'll want to manually press A to get to the save selection screen. In Pokefinder, if you want to verify what seed you're on, just in case you're off, you can do search calls or coin flip if you're playing Platinum. You'll want to use Elm or Irwin, so go to your Pokegear and do your calls normally. And it looks like we got the right delay, the right seconds, everything was correct. So then we'll just go collect the egg, because this is PID RNG, and the advances don't affect it. Here we go, collect the egg. Alright, the egg's gonna hatch, and it should be a shiny Gibble. And there we go. So this is going to be for Giratina, which is a Method J Pokemon. I just searched for one normally, this date and time, and this delay. Then, just like before, follow all the steps. Copy this first delay, put it here, copy the second delay, put it there. So you do want to be sure that you are inputting the correct values right here. I'm sure there's a way to like make a Python script or something that automatically creates this whole thing for you, but that's a little beyond my expertise. I'm using a spreadsheet, so every time you make a change, you will need to run dsm to bytes converter. Let's make sure that the file has been updated. Go to the save selection screen and wait. Alright, here we are. This RNG is going to require Chatots. Our shiny Giratina is right here, so go 1 frame before that. And here we are. Exit out of that. And this should be a shiny Giratina. And there we go. Alright, and that's it. If you have any questions, you can leave them, and I will try to answer. Thank you.